This is how the circuit works. First, we have the radio frequency transceiver. This component is responsible for communicating with the remote control. Then we have the voltage adaptation and transceiver protection. Then we have the power electronics. The power electronics control two components: the servo, which is used to control the vehicle direction, and the DC motor, which controls when the vehicle goes forward or back. To reverse engineer this circuit, we'll use an oscilloscope. This device will allow us to see the signals as they flow through the circuit. So we will use the oscilloscope probe to test different pins in the circuit. A sequence of pulses are sent to the DC motor. The wider the pulse, the higher the velocity. We call this pulse width modulation, or PWM. Okay, so those pulses that we found are not being sent directly to the DC motor. The pulses are fed to these optocouplers. So optocouplers isolate the digital circuits from the power electronics. We see that there are 4 MOSFETs. So we see them right here. And the MOSFET are the components that interact with the motor directly. In the case of the servo motor, the circuit also uses PWM, but in this case, the width of the pulse controls the position of the servo. Now, let me show you how we are going to control this thing using a Raspberry Pi. This is the diagram. We have a Raspberry Pi that will control these electronics, and then we'll communicate with the Oculus Quest 2 using Wi-Fi. I wrote the Raspberry Pi code using Rust with a tiny bit of Python. Let me know in the comments if you would like me to do a follow-up video focusing on the code. Alright, now let's go ahead and drill this thing. Alright, so let me show you real quick how the code works. Alright, this is better. Okay, so here you see the three elements: the camera, which is the Oculus point of view, the front camera and the rear camera. And then we added some code to each of these so that it knows how to stream images from the Raspberry Pi. So here's what I would like you to know. If the component is configured to be the controller, then it will send controller update messages to the Raspberry Pi. So that's how we get the thumbsticks position. When we receive images, all we have to do is load the JPEG to a texture and then render it. This is a bug in Unity, I think, where we need to manually garbage collect the frames just so that we don't cause memory leaks. Let me know in the comments if you would like me to do a deeper dive on how the Unity app works. Sweet. This is pretty cool. So now we can prove that the system is streaming. The latency is good enough. Actually, most of the latency is being introduced by the streaming back to OBS. For me, it looks great.